Hello, welcome once again. We discussed before about Hondas and Forerunners or RAV4, which this happens to be. Odysseys. Now, they're all the same thing basically. The starting system over here, this time I'm using the Chilton, which is a much better diagram to understand for beginners. For the reason that the layout is much easier. See the battery symbol? And you can follow it much easier than the other ones that I've been using. The other thing is it divides the system. So as you can see over here, this is starting and ignition system. These are ignition control modules and coils, and this is the power source. So it divides it so it's easier to see, to visualize for the beginner who's trying to learn diagrams. Again, a RAV4. Now, starting system. First thing comes to your mind, a relay. Second thing, engine control module, ECM. Computer controls everything in a car. Now, to make a point, people think that they're going to buy new cars and they're not going to need any repairs and things like that. The more newer cars you have, the more modules you're going to have, the more sensors you're going to have, the more parasitic drain you're going to have because of these modules or these electronic boards. You're going to have a lot of electronic problems. So, believe me, it is a new car that you're going to acquire, but still, more electronics, more gadgets in them. So, let's start from the beginning. The battery is over here. Now, if you start over here, you see the symbol is different for a starter than we're used to with the real schematics. This is what Chilton uses. Now, you see over here, there's a relay over here. Ignition to relay. So, as we always do, we always have to start from a point. Where do we start from? We always start from the coil side. This has to be energized first. Always start from this side, then go to the load side. In this example over here, we have a relay here. We have a relay here. What starts what? As you can see, this relay, what is it connected to? It's connected to the starter. We want to know that because we're dealing with a starter problem. Let's follow this one. This relay, where's it going to? If we look at the load side, okay, current will flow through a fusible link, if you can see it, 100 amp, from the positive of the battery, through another fuse, through the load side, terminal 5, I believe, come out terminal 3, follow the orange, and it goes to the ignition control modules, which gives it a spark. So each one of these will get, as you can see over here, B plus is always 12 volts. 12 volts, 12 volts, 12 volts for each one, each pin over here. This is the input, let's say. Where now there's another input coming from ECM. Engine control module is ECM. It'll program it, or it'll open up the coil to create the collapsing field, which will give eventually the spark. Now, since this has to do with the spark, we're not dealing with that right now. So therefore, we're going to concentrate on this part, the starter relay. We have a starter problem, we believe. We have to go to the relay, and we have to see how it's being fed. Let's look out. Again, same path through this fusible link, through this fuse, right? Through this fuse over here. And then this again goes to the ignition coil. We don't want that path. There's another path over here. You see that path here? That goes through this fuse, goes through this, goes to the ignition switch. Now the ignition switch has to be in a run or a start position. In the run position, ignition 2 run position, we have this relay being activated. In a start position, we have the start relay being activated. So let's follow the blue and then the green. Current flows from here. This is closed in a start position, which is in this position, going to the green. Going to this one, follow it this way. Which side do we deal with first? This side. Goes over here. One side goes to the ignition control module, the computer again. Then there's a park neutral switch. Now it's a little hard to see because this is the video is at night. Automatic transmission, AT. This is MT, manual transmission. That's why there's a clutch. We're dealing with this path, automatic transmission. We have to be in the park or we have to be in a neutral switch position. We come over here. We come out here. Either way, if I'm in park, I'm going in this way. This pin, which is 9. I come out over here, which is pin 6. Whether I'm in park, whether I'm in neutral, park goes here. We come out here. This is a jumper. We go into neutral. We go over here. We come out here. Either way, this is the connection from the terminals. They like to use this type of terminals. Anyway, which gives us eventually the ground. This other part gives us also engine control module. We have to look up where it's going to, probably to give us a ground, but we already have a ground from here. Let's make it simpler. we just activated this one over here, again, 12 volts over here. We close this switch. Which position do we close it in? To start, right here. This one, ST is start. The other one is ignition. You're going to start the ignition control modules. Now go over here. Now go over here. Follow this again. 12 volts here. 12 volts here. Why? Because it's just a switch. How do I know the ignition switch is good? How would I know that? Without taking apart the ignition switch. How would I know that? Let's find the point where it's connected to. Goes over here. 12 volts here. Let's go to the relay. Let's go to point 1 or point 5 of the relay. Then I know if I have 12 volts over here, guess what? This has to be good. Let's go over here. We said we go over here in a park neutral position. If I have 0 volts over here, what does it mean? That means the park neutral switch is good. When that happens, now we have current flowing, and this is closed. So terminal 5 is connected to terminal 3. Now we have 12 volts over here. How much do we have over here? If you had 0 volts, you're wrong. We have 12 volts. Why? Just a switch. We don't lose no voltage across the switch. We lose voltage across the coil. 12 volts here. Again, goes to engine control module. And one side of it goes to the solenoid to activate the starter motor. Finally, whenever you see this line, sometimes it's thicker, sometimes it's not thicker, and you see no fusible links or fuses, that's the heavy line that goes to the starter motor, the 200 amps, the 300 amps, whatever it is. There's no fuse over there. So, what's first? What happens first again? This happens first. Follow the blue, follow the green, this to ground. What happens next? This. Then we have this. Now, start a problem that we have. I don't have 12 volts over here. I have 0 volts over here. But I have 12 volts over here. As soon as you have a problem like that, you see or ask yourself, what's in between this point that I have a voltage and the point that I lost the voltage? What's in between those 2 points? If I have 12 volts over here and I have 0 volts over here, what's in between? The ignition switch is in between. And this wire is in between. So, if I have 0 volts over here, what can be the problem? The wire might be broken, or the ignition switch might be broken, not making contact. How would I know? I could go to ignition 2, go to the fuse. Do I have 12 volts at the fuse? If I have 12 volts at the fuse in the run position or ignition switch, I have 12 volts here then. That's how you would know. So therefore, again, 12 volts here, 0 here. What's in between these two? What components? The actual component is ignition switch. The wire is this one. This wire over here. So now, let's take another case. We're at the starter motor over here. I have 0 volts over here. 0 volts over here. But I have 12 volts over here. Ask yourself, where do I have the voltage and where do I lose the voltage? 0 volts over here at the solenoid. 0 volts at the solenoid. 12 volts over here at pin 5 of the relay. So I have it here, but I lost it here. First question you should ask yourself, what's in between those 2 points? The switch, the contacts. So, how do you diagnose it? What might be the problem? Could be the switch, could be the wire. Okay? Can it be that this is grounded, that this is 0 volts because it's touching ground? If that would happen, guess what? You'll blow the fuse. You would blow the fuse instantly. But I have 12 volts over here. That means the fuse is good. Pick 2 points. Again, I come over here. Instead of 12 volts, how much I measure? I measure 10.5 volts. If I have 10.5 volts, how much would I have here? 10.5 volts. That means the battery is not fully charged. I don't even mess with these. I take care of the battery situation first. I try to recharge it. Because in order to do this exercise, to go to the starter, you have to have a fully charged battery. If I have 11 volts here, I have no business of even trying to go and diagnose this circuit. I have to have a good battery of 12.6 volts, whatever, 12.4 volts, whatever, to even start analysis. Okay? Let's go over here now. I'll pick a point. I come over here, I'm at 12 volts. And I come over here, I'm at 12 volts. What's wrong? That tells me I'm not being I don't have a ground. I'm not connected. Can it be the park neutral switch is broken? It can be. Can it be the ground opened up? I'm not making contact with high resistance? It can be. If you have high resistance, you should have some voltage drop. So the problem is here. Pick 2 points and start from there. If I have 12 volts over here at this fusible link, over here, or this fuse that they use, whatever it is. Now, over here, I go over here, 12 volts over here, and I have absolutely 0 volts here. What's in between? I had it here, but I lost the voltage here. This wire could be the problem, or this link, or this fuse that they have could be the problem. I have 12 volts over here, but I have 0. What could be the problem? This fusible link. Why? Because it's only the only component in between. That's how you go about it. Anyway, please go to my channel, Joe Electronic Schematics for Auto. And then please go to my other one, Automotive Electronic Schematics by Joseph. Please subscribe, please. And try to watch some minutes so I can get some advertisements. It'll be great. Like I said, in one position, in the run position, you're activating the ignition coils. First, you start the system, right? Try to turn the engine. Then when that happens, you give spark. So, always pay attention to the relays. Always pay attention to the relays, number 1. Always pay attention to the computer, number 2. The wiring, don't worry about that when you analyze. I hope this was helpful and informative. Again, when you have 12 volts here and I have 0 volts wherever, between those 2 points, where did I have it? Where did I lose it? What's in between those 2 points? If I have 12 volts over here, and I have 12 volts over here, right? That means I am not grounded. Over here. This is ground. Look where this is connected to. If this is connected to ground, there should be 0 volts. That means I have 12 volts across this coil. Thanks for watching. Hope to see you next video.